This is R.D. Sharma Solutions, Class 10 Maths, Chapter 16, Exercise 16.1, Surface Area and Volume. A well with inner volume 4 meter is dug up and 14 meter deep. The radius is 4 meter and it is dug up 14 meter deep. Earth taken out, it has been evenly distributed around a width of 3 meter to form an embankment. Find the height of the embankment. So what is happening here is there is a well and now the content is being taken out and there is an embankment which is being made. Embankment. So the thing is that if I can tell you or I can show you the top view of the embankment, which is something like this. It will be something like this. This is the portion which is dotted here. This is the portion. So the outer one and the inner one, outer one and an inner one, when we take the difference of these two, that is the volume of the hollow well. Volume of the hollow well. The volume of the hollow well, basically this one will be, or you can say the portion, this portion will be equal to, this portion will be equal to the content which has been taken out from the well. So what is the volume of the well? First of all, means the content which is taken out from the well. It is, the given content is, radius is 4 meter and the height is, or depth is 14 meter. So it is pi into r square, which is 4 square, into h. 14 is the depth, so 14. This is the volume of the content or earth which is taken out, and this earth being taken out is converted into the embankment which is seen here. And how it is seen here, or how we can compute it? The outer radius means the outer volume minus inner volume is the embankment area. So what is the outer volume? Let us say that the radius of outer point is say the width of the embankment is given as 3, and the inner radius is already given, which is, it is being, say this is inner radius is 4, so here inner radius is 4 and the width is 4, the width is 3, so inner radius 4, this is inner radius, and the outer radius is 4 plus 3, so outer radius is 7. So we will just take the volume of the outer one, subtract the inner one, we'll get the volume this one. Pi into r square, which is the higher one, that is 7 square, h minus pi into 4 square, this one, into h. Pi, and what we get? 4 square into 14 divided by this 7 square minus 4 square. This is h. So when you compute it, h will come as 6.78 meter. This will be the height of the, height of the embankment, this one. A well of diameter 3 meter is dug up to 14 meter depth. The earth taken out, it has been spread evenly all around it to a width of, this is 4 meter. To form an embankment, find the height of the embankment. So same thing is going on. We have a well and the content has been taken out and an embankment has been made. So the volume which is coming out of this is spread here. So what is the volume here? The volume of the well, which is pi into r square, that is diameter is 3, so radius will be 3 by 2 pi r square into h. Height is 14 meter. And what is the volume here? This portion, the volume of this portion is the volume of the outer portion minus volume of the inner portion into the height. So what is the inner radius? Because 3 meter is the diameter, radius will be 3 by 2. So 3 by 2 is the radius, that is 1.5. And what is this width? It is given as 4 meter. So 4 meter, the inner radius or Ri is 1.5 and the outer radius is 1.5 plus this 4. So 4 plus 1.5 is 5.5. So the volume will be the outer volume minus the inner volume, that is pi r square, that is this outer one, 5.5 whole square h minus pi inner one, 1.5 whole square into h. So pi, let me cancel it, and then this is 3 by 2, so 1.5 whole square into 14 equal to, I am taking now the h common because h has to be found out, the height, 5.5 whole square minus 1.5 whole square. So 1.5 whole square into 14 by 5.5 whole square minus 1.5 whole square, and this is h. So I hope you'll be able to compute this. This h is going to come as 9 by 8 meter. This is the answer. Here because the volume of the earth which is dug out, the radius has to be taken as 1.5. This is 1.5, okay? Or you can say 3 by 2. 3 by 2. This is 1.5. Find the volume largest right circular cone that can be cut out of a cone of a cube whose edge is this much. So we have a cube. All the sides are equal, all the faces are similar. So this is a cube, and from here the largest right circular cone has to be taken out. So it will start from here, and this will be means the circle or the base will be touching the face, one of the face of this cube, and the top one will be touching the one of the face. So the height will be actually the length of the side, right? So what is the side of the cube? It is 9. So from here to here it is 9. So for diameter will also be 9 because it is touching both sides. So radius of the cone will be 9 by 2, that is 4.5. This radius we got. What is the height? See, from here to here it is 9. So the height will also be 9 because it is, this top is touching this face, and this base is on the base of the face. So height is 9 and radius is 4.5. So let us find out the volume of the cube. It will be 1 by 3 pi r square h. Pi is 3.14 and r square, you can take it as 22 by 7. It will be easier to compute. Pi r square, that is 4.5 whole square into h, which is 9. So when you compute this, it is going to come as 190.92 centimeter cube volume. Rainwater which falls on a flat rectangular surface of length 6 meter and breadth 4 meter is transferred into cylindrical vessel of internal radius 20 centimeter. What will be the height of water in the cylindrical vessel if a rainfall of 1 centimeter has fallen? So 6 meter length, 4 meter width and 1 centimeter is the height of the rainfall. So we have, say, a rectangular surface like this. Let me make it a very smaller one because the height is very less, 1 centimeter only. So this is the surface. Here the water came and this has shifted, or this has been taken to a cylindrical vessel. This cylindrical vessel. Now the length, breadth, height is given. This is 6 meter and length is 6 meter, the breadth is 4 meter and the rainfall 1 centimeter, that is 1 by 100. 1 by 100 centimeter I have changed it to meter. This is the height. So volume of this will be equal to volume of the cylinder being filled, because it is said that the cylinder has been filled, but we don't know the height of this cylinder up to which the water has been filled. Say it is filled up till here. So the internal radius, this one is 20 centimeter here. 20 centimeter height we have to find out. So the best idea is to convert, because this is into centimeter, this is into centimeter, let it be 1 meter. We'll convert this 6 and 4 into centimeter. So the volume of this will be equal to volume this, that is 600 into 400, length, breadth into height. 600 means 6 into 100 centimeter. So we convert it into centimeter. And what is the volume of this cylinder? Pi r square h. So pi into r square, which is the diameter is, the internal radius is given already, 20 square into h. So this h has to be found out. H will be equal to 600 into 400 by 3.14 into 20 square. This already cancels. 600 by 3.14 will be equal to 190.9 centimeter. This will be the height. A conical flask of water. A flask there is a conical flask. So this is a kind of conical flask. The flask has a base radius of r. The radius is r and the height from here to here, it is h. The water is poured into a cylindrical flask. This is a cylindrical flask. The bottom radius is r only. This is r. Okay, bottom radius is also r for this. Now find the height of the water in the cylindrical flask. So what is the water? Say up till here it is. So h is the height which we have to find out for, and this height is for the cylindrical flask. So let us say that this is hc. HC. So volume of these two we have to equate. What is the volume of the cone? It is 1 by 3 pi r square. R is the radius and h is equal to, what is the volume of this cylinder? It will be pi into r square, that is this r square into HC. So this pi cancels and r square cancels. HC will be, that is the height of cylinder, will be h by 3, the height of the cone divided by 3. This is the answer. So height will not be in meter square, okay, it is in meter only. If at all it is in meter, because the unit is also not given. So we can just say it as h by 3 units. The answer can be written like this. A rectangular tank is 15 meter long and 11 meter breadth is required to receive a entire liquid contents from a full cylindrical tank of internal diameter and length, which is given 21 and 5. Find the least height of the tank that will serve the purpose. So we have a cylindrical tank here, and the water from, or the liquid from here, has to be transferred to a rectangular tank, which is like this. So the volume of the cylinder will be equal to the volume of this one. Volume of the cylinder, where the internal diameter and length is given, is equal to the volume of this rectangular tank. So we'll just equate this. The volume of the cylinder will be pi r square h. So pi into r square. What is the radius? The radius diameter is 21, so radius will be 21 by 2 pi r square into height. What is the length? 5. Height, that is 5. And what is the volume of this cube? It is length into breadth into height. So 15 meter is the length, 11 meter is the width, and height is not known. Height has to be found out. So this total is, when we compute this one, h will be equal to pi. You can say take 22 by 7, and this is 21 by 2, that is 10.5 whole square into 5 by 15 into 11. So height will be equal to 10.5 meter. This is the height. A hemispherical ball of internal radius 9 cm is full of liquid. The liquid is to be filled into a cylindrical shaped small bottles, each of radius diameter 3 cm and height 4 cm. How many bottles are necessary to empty the ball? So there is a hemisphere here. Now this hemisphere, the internal radius, this r, is 9 cm. And this is full of liquid. The liquid is to be filled into cylindrical shape. This is a cylindrical shaped small bottles. So we don't know how many numbers of bottles are there. So we'll just take identical ones. We'll take the volume of this one, that is the hemispherical ball. We know the hemisphere. For the hemisphere, the volume is, it is, because the sphere is 4 by 3 pi r cube, and for hemisphere we have 2 by 3 pi r cube. I hope this hemispherical ball is 2 by 3 pi r cube, and you just have to change this to 2 by 3 pi r cube. Half is there, and this will be equal to the n. We don't know how many cylindrical this shaped small bottles are there, and the diameter and height is given. So n into the cylindrical, that is pi into r square, which is the diameter. So 3 by 2 r square into h4. So we have to find n. This n can be found out, and if you find out, this n will be coming to 54 bottles. This is how we have to do it. This is the idea behind this question. A cylindrical tube of radius 12 cm contains water of depth 20 cm. A spherical ball is dropped into the tube and the level of water is raised by 6.75 cm. Find the radius of the ball. So there is a cylindrical tube. In this, the radius is 12 and water of depth 20 cm. So water is at depth 20 cm. So are we going to use it? That's a question. Let us see. A spherical ball is dropped. So there is a spherical ball which is dropped, and the water has increased. So whichever water is there, say 20 was there, it has increased by 6.75. So the volume of the bottle being, the sphere being dropped, is equal to the raise of the water. So we'll use the height 6.75 only. That is, the volume of the sphere is equal to the raise of the water. So what is the volume of the sphere which has been put in? It is you say what radius we have to find. So spherical is 4 by 3 pi r cube. This r cube we have to find out. And what is the volume of the portion? This portion only we have to find out, 6.75. So it will be pi into r square. Radius is given as 12. So 12 pi r square into h. H is 6.75. We have to use 6.75 here. I hope you got the idea. Pi r square, 12 square into 6.75 you have to use, and 4 by 3 pi r cube. So this pi you can cancel out. So we have r cube is 12 square into this 6.75. This 3 goes up, 4 goes down, and this has to be taken as 1 by 3. Third root. So it is going to come as 9. So 9 centimeter, because eventually this will come as 729. So cube root is 9. So the radius of the spherical ball is 9 centimeter. 500 persons have a dip in a rectangular tank which is 80 centimeter long and 50 meter broad. What is the rise of the level of water in the tank if the average displacement of water by a person is 0.04 meter cube? So we have 500 people here, and these 500 people, one person is displacing water by this much. So how much water displacement done by the 500 people? 500 by 0.04 meter cube. So this is the total displacement, which is coming to 8 meter cube. This is the total displacement, and this displacement is nothing but the length, because tank is there. So 500 people are here, so some height of water will be displaced, or this volume of water will be changed. That has gone up because of the people dipping inside. So this volume will be equal to the length breadth, that is 80 into 50, then breadth, and the height is not known. What height, because of dipping, how much water level has increased. So let us say it is as h. H will be equal to 8 by 80 into 50, which comes to be 0.016 meter. So height increased is 0.016, or this is the height raise. A cylindrical jar of radius 6 centimeter. A cylindrical jar of radius 6 centimeter contains oil. Iron spheres, each of radius 1.5 centimeter, are immersed in the oil. How many spheres are necessary to raise the level of the oil by 2 centimeter? So we have a cylindrical jar here. And now cylindrical jar of radius this 6 centimeter contains oil. Iron spheres, so there are iron spheres being put in here. A radius 1.5 centimeter. These are immersed in the oil. How many spheres are necessary to raise the level of oil by 2 centimeter? So we just have to talk about this raise, 2 centimeter raise. Okay. So volume of this, how many, this one is, let us say that there are n numbers of these balls. So n into volume of one of these, because already given 1.5 centimeter. So we have the volume of one of these sphere will be 4 by 3 into pi into r cube, and this will be equal to the raise of height. So it will be pi into r square into height, this height 2. Okay, so now let me just put values, 4 by 3 pi, and the radius is already given here. This is r cube, and this radius is 1.5, so 1.5. This is 4 by 3 pi r cube. So this is 1.5 whole cube equal to pi. Let me cancel pi here. It is equal to r square into h. How many spheres are necessary to raise the level of oil by 2 centimeter? So height is 2 centimeter and r square, a cylindrical jar. How many spheres? So r square here, see, when we have 1.5, so 1.5 is the volume, is the radius of this one, which is 1.5 we have used. And how many spheres are necessary? Because the cylindrical radius is also given. So this is 6 square. Okay, 6 square into 2, and this is n into 4 by 3 into 1.5 whole cube. So n will be equal to 6 square by 2, and this 3 goes up, 4 goes down, and 1.5 whole cube. And this n comes to 16 spherical balls. 16 spherical balls. So these are the questions. Few of them we have taken, and few of them is still remaining, so we'll be taking in the next discussion. Till then, thank you so much. Take care of yourself.